In this chapter, we'll start looking at working with 3D in Notch. I'll give you an overview of Notch renders and setting up lights in 3D. Then we'll look at giving your 3D objects materials through the use of textures, including advanced materials from Substance Designer. We'll also use the skills learned from the Post Effect and Video Compositing chapter and use them to modify our texture maps. This chapter is another workshop, so please follow along with what I'm doing in the tool and repeat the actions for yourself. Okay, next on our list is rendering lights and materials. This will be a bit bigger chapter. I will start with giving you a bit of a 101 on how rendering in Notch works, what are NURA renderers, and what are the differences between them, and what are the practical applications. Rendering in Notch is rather simple across the board, allowing you to switch from real-time to high-end rendering with just a single node change. No need to adjust materials or lighting settings. Notch offers 4 rendering options, all of which are accessible as nodes in the node graph, making them easy to switch between. So it's standard, hybrid, smart tracer, and a path tracer. These 4 renderers form what we call NURA, the Notch Unified Rendering Architecture. So here I have a sample created by our team that highlights all of them, and we can switch several lighting settings to see how all of them look when used with one or the other renderer. Let's take a closer look at each of the 4 renderers and what you can expect from them. Let's start with the path tracer. This is our native GPU-powered path tracer, the gold standard for graphics rendering when you have the time to wait for great results. And the reference for the others, more speed-focused renderers that I'll cover in a bit. While it's our reference renderer, it doesn't compromise on speed or scalability. It utilizes our own GPU optimizations and the latest sampling techniques to minimize required refinements and incorporates AI denoising from NVIDIA and Intel. So path tracer is useful when you need a highest fidelity renderer and when you require massive scalability and determinism is critical. Next up, we have the smart tracer. This is essentially our path tracer with a speed boost, bringing the new levels of interactivity and performance using the latest GPU-based ray tracing acceleration algorithms. The smart tracer is built on cutting-edge ray tracing research. It uses many of the same lighting calculations as the path tracer, but accelerates them using spatio-temporal path guiding and reuse via raster. This dramatically reduces the number of passes required for final quality render, from thousands to tens or even just one in some cases. So Smart Tracer is ideal for projects where clients need high quality rendering but lacks time or budget for pure path tracing, or achieving near final render quality while maintaining interactive frame rates. Next is the hybrid renderer. This combines high-speed rasterized rendering with ray tracing features, quality and scalability. The hybrid renderer takes the best of rasterization techniques and enhances them with ray tracing. Real-time projects need speed as well as flexibility and responsiveness. This renderer offers options ranging from fast real-time all the way to high-quality offline rendering. The included ray tracer mode, for example, lets you handle polygon counts into the billions. You will want to use hybrid render when you need features that standard renderer can't provide, or when you're scaling across multiple machines or GPUs. And finally, we have standard renderer. This uses classic real-time rendering techniques to provide the fastest possible rendering with a solid set of artistic features. It fully supports Notch materials, and Shader Graph offers a complete range of light types and includes streamlined set of effects to ensure real-time frame rates with instant response. It's great for both real-time show critical 3D as well as high-end 2D work. You will want to use standard renderer to work on things like video effects, interactive installations on a single GPU, lower polygon counts, and projects where you don't have access to high-end GPUs, either while working on or while deploying to a media server. So with all of that out of the way, let's get a bit more hands-on and look at the lighting in Notch. I will start by heading to Lights Finished Composition. This is our reference point for different light setups that we will be trying out. So we will be covering skylight, spotlights, Omni Lights, volumetrics, area lights, and video or texture emission from spotlights. For these workshops, we will focus mainly on standard renderer. Flick back and forward to Path Tracer for comparison and reference. So let's get started. Okay, so let's flick to the lights start and let's start looking into lighting setups. First of all, I will add a skylight. So as you see, there's a couple of nodes and the one that I'm actually after is the skylight, the last one here. So I will connect it to the root, and you may have noticed that first thing that happened, a little outline of a node popped up. Now, if that disappeared for you, you can always double click on the output and it will reappear. So this is what we call hints. So hints works with quite a few nodes. So it helps you to find the best extra node to go with it. And it really helps when you're just getting started. So again, if you lost your hint, you can always double click on the output and it will come back. So the skylight node works together hand in hand with environment image. And environment image requires some kind of either HDRI image or our native daylight HDR node. So as soon as I add that, you will notice that our setup changed quite drastically. So now we have skylights running and it's using environment image, which in this case is daylight HDR. Now the cool thing about daylight HDR is the fact that we can change the sun elevation and azimuth. So basically we can simulate any specific time of a day. So this is really, really powerful when you just want some nice, consistent lighting in your scene. Now, obviously, this is not the only HDR that we can use. Actually, if you look at your resources, you will find that you have a little folder and there's at least 3 options for you. So I'm clicking Control and I'm going to bring them all in. So let's put it somewhere here. First of all, let's make sure that they are tidy. As you see, they're overlapping and I could put them neatly one after the other by hand, or I can actually use built-in features for node arrangement. So I can go horizontal, I can go vertical, or I can put them in the grid. I'm going to go for vertical. Now I even have a chance to set the distance between them. Cool. So at this point, I'm pressing Control Shift and I will delink the daylight HDR. And I will go for the first loader, and that's Golden Gate Hills. I can preview how that looks. So we can use that as the HDRI image. All we have to do is pipe it into the third input here. Another option we have is the Leather Lane Market. And as we've spoken in the video chapter, you can change HDRs and textures just by going to the drop-down of the video input here. To be honest, I'm quite happy with this Leather Lane Market option. One thing I will do, I'm going to go to Skylight, and I see that there's a property for me to change, which is Visible Sky Dome. So I'll turn that on. I actually do want to see that HDRI in my scene for the reference. Obviously, the very skylight has properties for lighting and dome radius. At this point, we will leave them as they are. So I will just delete the extra nodes. I will leave this skylight setup as it is. And before we move on, I will mention that there's abundance of HDRs available online. My favorite place to get them would be HDRI Haven. This is completely free service and you have a lot of choices. Anything from skies, outdoors, indoor studios, you name it. So you literally just pick and choose whatever you feel fits your scene. And you just grab the HDRI of the size that you want. So before we move on to any other light setups, I think it's good time to add a renderer, and that too will have an impact on how this scene looks. As mentioned, in this workshop we will focus on standard, but we will check it against path tracing. So with that said, let's add a standard renderer. So I'm connecting that to the root. And now let's just go through most important properties of the actual renderer. First of all, we can look into anti-aliasing. So we have an option to turn it on completely, or we can use the default MSAA. And this anti-aliasing option samples geometry 2, 4, or 8 times to reduce anti-aliasing on geometry in the scene. So it will slow down if there's a lot of geometry in the view. So just keep that in mind. And as stated, you can tweak it to less samples if you choose so. But the default 8 is rather good in my opinion. Next in our list is DLSS. This one uses NVIDIA's DLSS to resolve anti-aliasing. Often works faster than MSAA, or Edge AA, but can introduce artifacts. So that's something to look out for. And then we have temporal, does a decent anti-aliasing job for a relatively small cost, but can make scene appear blurry or jittered in some cases. And then the last option we have is refine. So this one samples every pixel multiple times per render frame, greatly improving anti-aliasing and also smoothing out some temporal artifacts. This is not suitable for live output though, but the perfect choice for video or still rendering. So that's not something we're going to choose now. I think we're going to stick with the default MSAA, and mind you, defaults in all of the renderers are rather good. You don't necessarily need to tweak them too much, but it's good to know what options you have. So if we move further through the important properties, there's a depth of field. We don't need to focus on that now. If quite self-explanatory, is it off or on? That's your choice. Same with the motion blur. Then it's transparency sorting. We're good with the default per node. Max output luminance. This sets a limit for the brightest possible value a pixel can contain. This is mainly applicable for the specifics like HDRs. In this case, again, the 5, the default is really, really good. And now we're moving on to lighting, so you can switch it on or off. And the next property is shadows. This will be much more relevant when we're going to start to work with omnis and spotlights. But basically here you can choose the size of the shadow map resolutions. And of course, how far do they stretch? Then we have reflections that we definitely want to turn on. We have refractions. We do not have any glass surfaces here. So for this moment, this doesn't really change much for us, but let's keep it on as it is. And then there's ambient occlusion. That too, I think it would be nice to turn on. So I'm going to go for one option that we have, which is to use ambient occlusion in a screen space. And here I can tweak the way it looks. It's much easier to see it if you go for replace or add. I usually keep the AO distance rather small and don't really change other properties that much. And then we have scattering, and we will come back to scattering when we're going to start to talk about volumetric lights. So for now, I think this is rather good. As I said, as a reference, we can add a path tracer. Now, rendering nodes are mutually exclusive, so you cannot run them both at the same time. So what I'm doing, I'm just disabling one of them, Control 1, and now path tracer is in full swing. We will not cover all of the properties here, but the most important things to remember is that this is where you set the refine times, and you can actually see it here in the bottom. And you can turn on one or the other denoiser, for instance. Let's go for Intel Odin. And you have two options. Is it refining per refine step or after refining? I usually go for after refining. So once Notch has done his job, then the AI denoiser is applied on top. Let's push it a bit. So let's set it to 400. There's the ticker, 400 is done. So this is our scene in path tracing, and this is our scene in standard. Cool. This is a good time now to look into spotlights. So I will disable the skylight, so Control 1, and I will start adding spotlights. There we go. Let's connect it to the root. Now, again, Spotlight came into the center of the node graph, and it's a little bit behind all of our setup. That's why things got dark. But if I pull it back, I start to see the spotlight lighten up our geometry. I think I'm going to push it a little bit higher, and I think I want to put it on an angle. I'll put this one on minus 45 degrees, and I want this to go downwards. That too can be 45. There we go. And now I can position it closer to the geometry. Yeah, I'm quite happy here. Well, let's add one more. I'm adding a second spotlight connected to the root with the Control R. And this one could be from the other side. This too could be on something like 45 degrees angle. I don't necessarily have to follow that, but it's just a good number to round up the positional and rotational values. There we go. Yeah, I'm quite happy with this. Now let's change a couple of parameters in the spotlight. First of all, I think I'm going to color them a little bit different. So the first one could be a tiniest bit more shaded towards the red, and the second one could be shaded a little bit more towards blue. Cool. Another property that is worth knowing about is brightness, obviously, the cone angle, and attenuation distance. So this property tells Spotlight how far should it stretch. And we could tweak it to our liking. Sometimes you might want this property to be rather small, or the light distance to be relatively little. Cool, and here we are, we're using spots. Now, omnis, I will disable the spotlights. Omni lights are rather similar to spots, except they don't have a cone. They are throwing light to every single direction available. So it's like a little 360 bulb. So I'll place it here. And I will place the next one, let's say here. Let's see how it looks through camera. I'm pressing 0. Yeah, this is becoming a bit more exciting. I will reduce the attenuation distance. Maybe I'll put it somewhere here. How about one more? There we go. And this one could be in a forefront, so maybe somewhere here. And again, I can give this one a color, because why not? Or a shade of color instead. We are not obliged, by the way, to use specifically one or specifically other lighting. We can mix and blend. So if I want to use spots and omnis at the same time, that's absolutely fine. We can even add a skylight to the mix as well. There we go. For now, if we are actually mixing, I think I would disable the visible sky dome. And our scene is becoming a little bit more dynamic, a little bit more interesting in lighting. Let's double check with the path tracer. Yeah, kind of cool. All right, so we've discussed skylight and how to use HDRs. We've discussed spotlights and omnis. I will disable them all, Control 1. And now we will look at the volumetric lighting. First of all, every single omni and every single spotlight can be volumetric. For this example, I'm going to add a spotlight connected to the root. And I will rotate it and place it just above our setup. There we go. And now if I go to the spotlight's properties, you will see that there's scattering intensity. That's exactly where I can enable the scattering. And I definitely see it working now. Now I can further tweak it by going to the renderer. You remember we had a whole scattering bracket. So here we can set global intensity and we can tweak that a little bit further light by light. And we can set smoke density. So it actually starts to look like a smoke simulation here. And we can address the scale and even speed. So this is one way of setting up volumetrics. There's another node that is very handy in this space. And that's fog scattering. So if I connect it now to the root, I can set how far and how dense the fog is. I can even change its sun pitch and heading. And of course, recolor it to my liking. Quite handy when you need this atmospheric look or a background filler in your 3D scene. I'm going to reset it back to default because I don't think I made the right choice there with the colors. Yeah, so these are the volumetric choices we have in our scene. And then the next on our list is area lights. So area lights are huge quads that can be used to light up scenes. They are very, very customary or very, very usual in something like product lighting. If there's a car, if there's a specific thing you want to light up, usually one would put it quite above, make it extremely big, and that gives you the nicest light possible for product shots. We can double check that with the path tracer. There you go. Lovely. Now, mind you, one thing to remember. Area lights do not throw shadows in a standard renderer. So in a standard renderer, we get shadows out of omnis and spotlights. That's just something to keep in mind. However, if you switch through to path tracer, you definitely will get the shadows. Cool. So if we look into this area light a little bit more, there are a couple of properties that's worth mentioning. So first of all, you can choose to have the surface visible or not. Depending on what you're building, this might be important. And this area light can be double-sided or not. So in this case, it's one-sided, as you see, but we can choose to have it double-sided. And you, of course, can pipe in textures or videos to this spotlight to make it a little bit more exciting. We already looked into a fractal noise generator. We might as well use the same thing for the area light. There you go. Let's make it a bit more prominent. And you can see how that is now applying on the area light. If we make it a bit more aggressive, you can see those shimmers now on the 3D objects. And that's true to any type of texture or video you want to use. You're not bound to just generators in Notch. If I go to the video bracket, I see that my videos are linked correctly, just like in a previous workshop. If yours are lit up here red, make sure to go for Find Missing Resources and just navigate to the appropriate place where you're keeping your essential course, assets, video. So with that done, I'm gonna grab the dark sky loop and I will pipe it into the first input here of the area light. It's a little bit harsh. I can see that I overdid with the brightness. So I'll bring it back to the default. And I can see that that is being applied as well. Right, so I'm disabling the area light. And I will bring in a spotlight. Cool. Just like before, I will place it above the model. And now I'm going to use the very same dark sky loop to drive the spotlight to. And now we're emitting this video and applying it on all of this scene as a dynamic lighting property. Now to make this pop a little bit more, we can even add some scattering here. There we go. So these are the basics of lighting in Notch. It's rather straightforward. There's nothing too complex about it. You have abundance of options for lighting. You can mix and blend them. And the only thing you need aside of the lights in your scene is a renderer. And you choose the appropriate one to the scene that you're building. There, I think I will leave my scene with these lights turned on. Okay, so before we delve into the material properties and start to mess about with that, let's just get a little bit more familiar with the scene. First of all, here at the left, we have a studio background. Then we have a lighting setup here that lights up the 3D objects, a camera, and a couple of renderers already set up for us. So a path tracer and a standard renderer. We'll stick with the standard renderer for now. And then we have all of those 3D primitives and some imported 3D models that we will apply textures to. So let's start with the first one, this sphere right here. And let's apply some texture maps to it. Now you will notice that if I press on a 3D model or a 3D primitive, and if I scroll to the bottom of the properties list, you can actually tweak materials directly in the node. And that's very handy for some situations. But usually the best practice is to build out a separate material node. So I'm going to do that. I'm going to grab a material node and I will connect it to the first input here of the sphere material. And notice, as soon as I hook up the external material node, the internal properties is being overwritten, and that's by design. There we go. So if I now choose this material to be colored, let's say yellow, it becomes yellow. What is the benefit of using external material nodes? Well, I'm not bound to use this material node with just one 3D primitive or one 3D object. I can actually connect it to a number of them. So this is where things become a little bit more flexible and a little bit more interesting. So I'm going to unhook it from the second primitive. And I will reset the whole material to its default state. There we go. And I think I will apply copper textures here. So as you see, we have quite a few maps here available for us. Base color, normals, roughness, and specular. We will use them all. Now, we can call out all of those texture maps inside of the node. So if I scroll a little bit lower, there are textures bracket. And I can choose the color texture and just choose it from the drop down here. So copper, base color. There we go. Now that's of course a valid way to do that, but again, to retain the flexibility and to be able to further tweak or reuse that same texture map, I would always advise to grab that from the resources and connect it directly to the material. And you will notice that all of these drop downs are corresponding with all of these inputs here in the bottom. So texture, diffuse, specular, emissiveness, metallicness, roughness, so on and so forward. So again, I'm resetting the material now to default state. And I will grab this copper base color and I will apply to the first input, color texture. There we go. And I think the next one I want to use is the normal. So I'm going to grab the normal map. And the normals will connect here to this input. It's very handy to just hover over and see which input corresponds with what texture map. So there we go, normals. And I can see the normals being applied. So what does the normal map do? Well, it actually emulates or gives this impression of depth. So you see there's already these little dents and imperfections appearing as soon as I add the normal map. Very, very handy way to add details to your model without introducing extra cost of, let's say, displacing the geometry and adding subdivisions. Okay, next I will use is probably going to be copper metal. So let's bring that in. And let's just find a metallicness input. Good. Now I can head to the material and find a metalness property. So I will drag it all the way to 1. Now, metallicness is on or off setting, basically. There is no in between. If you need to build something like plastic or rubber, I would not suggest setting metallicness halfway through to fake it. I would suggest to tweak the specularity. So specularity or specular intensity is what's responsible for making all of those choices for plastics and rubbers, all the other shiny things which are non-metal. Metal should always be either off or on. Fantastic. So I could of course use this metallicness property without any texture map, but this helps. But this texture really helps for a notch to understand where should the metallicness apply and how. So there's one more texture that I would like to bring in here, and that would be the roughness. So let's add that in, and let's find the roughness input. There we go. It's this one right here in between the two ones that we already use. And for the roughness, I think I'm going to push it all the way as well. And I think I'm going to drop down the normal intensity because it's a little bit intrusive. And I think I want the color map to affect the specular color too. There we go. Now this starts to look definitely like copper. And that's sort of the whole process of using material maps. You just find appropriate input for appropriate material, and then you tweak the specific parameter a little bit further to your liking in the actual material. Let's try to set up one more, the sphere right here. And for that one, I'm going to use something else. For instance, rock. I'm going to go for rock. I will select all of the available materials and I will bring them into the graph. There we go. Again, I'm going to use alignment tool to make sure that they're all neatly aligned for me here. So what do we have here? We have height, we have normals, we have glossiness, and we have base color. I think I want to have base color as a first one. Shift double click to preview it. And then height, we can put it later. Normals could be the second one here. Glossiness, yeah, glossiness as a third one works. So base color, normals, glossiness, and height. Let's add a material node and let's start applying it. So I'm going to apply the base color to the first input. There we go, that's working. And then I want to apply the normals. Let's just look at this sphere from a little bit closer. So here is our normal input. Great, I can see it already taking effect. There we have these little small, nice details applied. And the next one is glossiness. Now, there are no industry standard naming conventions for something like roughness. So sometimes it might as well be called glossiness. So the glossiness one I'm going to apply to the roughness input. And now I want to go to the actual node and increase the roughness too. I can see how that's applying here in the preview as well. Just in case you haven't noticed, we have the whole preview system available for us too. And then the last one is something we haven't used just yet, and it's the height or displacement map. Usually these come in black and white. In this case, it came red, and that's totally fine. We can actually convert it on the fly in the actual nodes. So if we go for the format conversion, we can go for, let's say, RGBA 8 grayscale. There we go. This will help us much, much more. And I'm going to pipe this into the displacement input. There we go. So it's this one right here. And now if I come back to the material, I can find a displacement slider. And if I start working with it, you will see that now this material is displacing the geometry. So I'm going to come back to the camera view. And I'm going to tweak this displacement a little bit more. I think it's a tiniest bit too aggressive. Let's leave it somewhere, maybe here. Now, mind you, if you would try to apply the very same material here to this sphere, these two might look a little bit different. And why is it so? Why this one has more details than this one? And that is very easy to explain. I'm going to hit Shift R, and now I can see the wireframe view of the nodes. So as you see, this one is much, much more dense than this one here. You can, of course, change that. If we're talking about notch primitives, this is a parameter you can tweak. So this sphere is subdivided by 300 by 300. And this sphere right here is only subdivided 60 by 60. So I can change that and set this one to 300 by 300. And you will notice that these two materials now look rather closer in their detail. I think default in Notch is 20 by 20, and that of course is very good for optimization of your performance. But if you want that high fidelity details, you definitely want to bump up these numbers. Cool. So before we wrap up our conversation about this texture map, I will just mention that the color palette here is really not that great. I would much rather have this a little bit more brown or gray, because this doesn't look anything alike to a realistic rock. And I can do that by tweaking the color map. So all these things that we've learned and applied in the video processing chapter is really handy here too. What I'm going to do, I'm going to grab a color correction post effect, and I will apply it directly on this base color. So now I want to desaturate it a little bit. And perhaps hue rotate it a tiniest bit. Yes, something here already looks much, much better. Should we have more contrast? How about tweaking some brightness? There we are. So we don't need to bring a texture to an external package like Photoshop or whatnot to change its colors or to change its properties. We can actually do all of that directly in Notch. And that is why I find nodal system so very powerful and so very handy. Okay, so I'm quite happy here. Let's move on to the next one, this sphere right here. And we've already spoken about metallicness a little bit, so let's just solidify that by making a metallic texture. So I'm going to add a material, connect it to the first input. All I want to do in all fairness is just slide up the metallicness property. Now I can choose how rough it should be. And I, of course, can apply specific maps as we did with the previous examples, but this is the easiest way to set up a metallic texture. Now, as mentioned, if you want something like plastic, you will probably tweak the specular intensity and roughness. This is where the trick, or this is where the magic will lie for that. So I'm resetting, and I will make this metallic and a little bit more rough. There we go. Okay, next on our list is substance materials, and I think I have one of those available here for me. And it's grunge metal. So if I connect to the sphere, I see it's already applying. And now I can tweak the parameters of this substance material. I can choose what would be the size of this texture. So I can go really high, maybe 4K for instance. And as you see, we already have more details here. We can change dirt, we can change age. We can even tweak the luminosity of it. Now, maybe that's not a good one to change. I can even change the random seed. So this is a very dynamic material node that you can build out in a Substance Designer. Now, this is a part of Adobe package, but it's a node-based system that allows you to build dynamic materials. And then, of course, you can choose to export those and use those across the board with other packages, Notch included. I find myself using that quite a lot, especially if my brief requires me to be able to change the dirt properties of the material over time. That's just a great, great asset to have in your toolshed. Cool. Next on the list is glass material, and it will be this sphere right here that we will apply the glass. And to do that, all we have to do is type in glass material. And here we are. It is working on this scene. Now, obviously, in a standard renderer, we will not have the best looking glass. For the best and most accurate glass, I would say we have to switch to path tracing. There you can see all of the nitty-gritty like refraction and aberrations working exactly as they should, or exactly as you would expect them in real world. But I'm switching back to standard, and let's see if we can tweak a little bit this glass material. I think I want the tiniest bit of aberrations here. There we go. Okay, next up, let's look at the geometry specific materials. In this case, we have imported 3D model of this lion head. And I've already connected the material to it. Now, all we have to do is apply textures to it. So let's just see. There is our lion, and it has diffuse pass, metal, normal, roughness, and specular. So I will choose to bring them all. Let's just make some space, and I will apply them one by one. There we go. First off, let's start with the lion diffused texture. Again, there is no good standard for naming conventions in 3D. So in this case, the diffused means color. So once you download the 3D model with textures, don't get surprised. Sometimes it could be called color, base color, or diffused. Very much depends on where you're getting your assets from. Okay, let's pipe that in. That works. The next one we have specular. Let's find input for specular. That too is now applied. And then let's go for the normals. Let's find input for the normals. There we are. We already have a bit more details there. And then one more, there's metalness. Let's find that. There we go. So for this to properly kick in, we probably will need to go into the material and slide the metallicness property on. Fantastic. And now we have roughness. Let's add that in too. Emissiveness, roughness. So this too needs to be enabled. There we are. And just like before, we do want color map to pick specular color. Maybe a tiniest bit less metalness. And maybe a little bit less of normal intensity. Yeah, I'm quite happy with this material here. Let's see how it looks if we switch to the path tracer. Lovely. We can even change the color of specularity. Something like that, for instance. Yep, lovely. That's nice. Okay, let's move on to the next one. And that's yet again geometry specific materials. We will be looking into this spray can. So let's find that in our resources. There we go, spray can. So it's color, it's metal, it's normals, and it's roughness. Fantastic. Let's bring them all in. What do we have first? Normals, metal, color. I'll start with color. There we go. It's applied. And then we're going to go for roughness. There's our roughness. Let's slide that on as well. Nice. Then we have normals. That's applied. And now we have metal. Let's find metal. Emissiveness, specular, metalness. There we go. That too then goes full on. Fantastic. So how would we make this texture a little bit more interesting? I'm going to switch back to the standard for a minute. Well, we can actually animate some of the texture maps. So we will use a technique that we've learned in the video processing. We're going to use composite sources to animate the color texture of this spray can. So I'm adding a composite source, and I will disconnect the color texture from the color input, pipe it through composite sources, and then connect it back. And now I want perhaps some kind of a generator to be composited together with this color texture. How about a fractal noise from the generators? I'm gonna shape it a little bit. So first of all, I definitely want this to be bigger. So 2048 by 2048, that's a good size for us. And I think I want more interesting looking fractal noise, maybe warped. And I will increase the threshold, and I will increase the amount a little bit. Cool. And then I'm piping it into the first input here in the bottom. And there we are. It's applying and it's animating on this 3D model. I could even give it a color. So I can do that either in a fractal noise level or in an actual material. Now I want to do it in a fractal noise level. There we go. Maybe it could be orange. Should I do that in a material level, it would actually affect both of these textures. So I prefer to do it here locally in the fractal noise. And it's a little bit fast, so I see that there's a property for animation speed. I will reduce that quite significantly. There we go. Maybe a tad more. Nice. So what do we have left? We have animated material left to set up. So let's do that. So I'll bring out a material node. I'll connect it to the 3D object. And I think I'm going to use just generators for this. So first I'm going to give it a color texture. How about something new from generators? How about the truchette here? So I'm connecting it to the first input. It's applying, fantastic. I do want this a bit bigger, so maybe 1024 by 1024. And I do like the rounded turned off. That's just a little bit more interesting looking texture for me. Can I shape it a bit more? Maybe a bit more resolution? Put it to 8, and I'll set the thickness to 0.2. Cool. That looks quite nice. And then just like we did displacements with a static texture, we can actually do displacements with animated texture too. So how about the very same fractal noise? And let's just pipe it into the displacement. So I'm going to slide the displacement slider up. Now, if I wanted to tweak this further, I would probably then play around with the fractal noise and tweak its maybe, let's say, gain to achieve some different looks. But basically that's all that it takes. And all of the post effects that you've used in video processing, that too applies here. So for instance, I can add something like a block glitch to the color texture. There we are. I can use the very same block glitch to drive the fractal noise too. It's a little bit crazy, but I guess you see the point. All of the post effects and all of the video processing techniques are applicable here in a material and material level. And you can use them in any shape and form to your liking. Right, so to round up this workshop, let's look at the last two scenes. We have a little scene with a couple of buildings and a couple of FBX models that are moving. And what we want to do is use some 2D textures to fill the backgrounds and some lights to sort of make it a little bit more cozy and interesting looking. So let's get on with that. Let's see first what we have in the scene. We have standard render. We have this billboard here that we can use for video emission. For instance, we have a camera that we're looking through right now. And there are these three buildings. And of course, these are our three human figures right here. What I'm going to start with, I think I'm going to add some Omni Lights here. There we go. As I mentioned before. Anytime you bring in a light or a camera to the node graph, it will come into the very center of the graph. And that's why everything blacked out a little bit, because it's literally in a center here, and some of the geometry is just a bit in the way of this Omni Light. And yeah, let's start painting. Let's just start adding some little details here and there. Maybe this Omni Light could live here, and I think the attenuation distance could be a little bit smaller. Something like that. I'll make a copy of this, connect it to the root. I want a little detail right here as well. There we go, not too bad. And I actually want a light that would cover the whole scene, so maybe a skylight. And I do want this to use HDRI, so that's why I'm clicking through the hints and I'm grabbing that. Now, while I'm on it, it's probably worth mentioning that this is not the only way to bring out this skylight setup. So I'll delete this. If I type in sky, you will notice that there's a skybox. That's not something we need now. But then there's skylight, but we were using an HDRI skylight. So this is a pre-made cluster. So all of these nodes that we were setting up manually, they're already preset for me. So this cluster is just something that we anticipate that you will find handy time and time again. I'll disable the grid for now. And I will reduce the skylight. It's a little bit rough. Or it's a little bit too intrusive. And I don't want the sky dome to be visible. So I'll tick that off. And I think next thing I'm going to do, I'm going to use some image planes to work out the background and to add some fog to the foreground. So let's go for the image plane, connect it to the root. And this one, I want to be in the back of everything, and I want it to be rather big. There we go. So it's filling the whole background. And to drive this, I'm going to use dark sky loop. So just like with the image 2D, I just have to connect it to the first input, video node. Now there's one more thing I want to do here. This video file is worked out as a 16:9, but now we're applying it as a quad. So I have two options. I can either manually change the scale X to make it wider, or I can choose a pre-made option for me, aspect-based scaling mode, and choose scale by X. There we go. That's quite much nicer. And I don't necessarily think that this color palette fits with the rest of the scene, so I can address that, but I'll probably look at that a little bit later. Now I want another image plane in the foreground to make that fog. So, yet another image plane, and I will navigate and find the befitting video file for that. So let's just see. Video, smoke. Connected to the first input. We do want this to scale by X. So aspect-based scaling mode, scale by X. And we do want this rather bigger. There we are. Now, one more thing I want to do is to take advantage of its alpha. So either I would have to change the blend mode to something like additive, or I can pipe the very same video to the second input alpha image. One or the other, both of those in this case works. I'll stick around with this, piping it to the second input. But I don't think it's really that good looking just yet. So just like I did in the video processing, I'm gonna add a null. And I will make some tweaks before it actually goes to the image plane's alpha image. So color correction, and let's see if we can make this a tiniest bit better. What happens if we change its contrast and brightness? Yeah, there we go. This I like a little bit more, and it probably could go down a little bit. So, as mentioned, all of the things that you've learned in the video processing is absolutely applicable in your 3D scenes. In fact, I'll make a copy of this image plane. And instead of just pasting it, I'm going to Control-Shift-V paste it. Now, why I did that? I do want to retain the inputs. And by clicking Control-Shift-V, I'm pasting the new node with the inputs that they were already set. And I want it a little bit higher. And stacking order is important here too. I want it above the initial one and further down in between the buildings. Could be bigger still. There we go, now it's getting somewhere. I'll add a couple of more omnis or spotlights. There we go. Maybe one more. By the way, you don't have to follow exactly what I'm doing. This is a freeform workshop. Just everything we've tried and talked about, this is a good place to try it out and to apply it. What else could we do? Well, let's come back to this sky. Like, that doesn't really look nice. And that's because it's just giving me this hard edge. What if we wanted this to be a little bit more faded? Something like having a vignette, for instance. So let's just find that image plane. That's the one. And let's add a gradient to the alpha image. So generators, gradient, that goes here to the alpha image. Let's shape it a little bit. Let's make it 1920 by 1080. And we don't want this linear, we want this radial. And now we can position it and tweak it. So could it be a bit wider? Yeah, something like that. And inner range could be bigger. This already is starting to look like something. I think one more thing I want to do is add a LUT to bring this all together. So do we have any LUTs here available for us? Yes, we do. So I'll just grab one of those, connect it to the root. Yeah, maybe let's just reduce it a little bit. Fantastic. I mentioned the billboard here, and we can take advantage of that too. We can, of course, pipe in some kind of a texture to it, or we can pipe in a live video. So I would say let's add a material, and we will pipe it to the third input here, object screen. And let's use this test feed as a color channel. There we go, it's working. Couple of things we need to do. First of all, in the material, I'm going to go ahead and find the emissiveness property. So I'm going to tick off the emissive lights to scene. We don't need that, but I'm going to increase the emissiveness. So it looks like this is an emissive surface. Now, another thing I'm going to do, I'm going to go to the test feed and I'm going to flip the image. In this case, I want this flipped on a Y. And I think it would make do with adding a couple of post effects here. So maybe something like color correction. I will make sure that it's desaturated, and maybe something creative like VHS scan lines. Why not? And maybe a little bit less intense. Okay, one more thing. I see I have these light strings, so I can select it in a viewport, and if I press F1, I will be brought directly to that specific node. There we are. I do want those to have a texture and perhaps look like they're emissive. So let's see what we have as inputs. So let's make a material. And if I hover over the inputs, I will see that the one that I need is the third one. So I'm holding Shift and I will connect the same material to all of these nodes. And then in the material node, I can choose to make it emissive. Now, standard render does not support global illumination. However, were you to switch to path tracing, this then becomes emissive. Let me show you that in a materials finished setup in practical terms. So first of all, I will disable the lighting setup that we have here. I will switch to path tracer and I will add a primitive. There we go. It's all blacked out because we don't have any light source. And for that, I'm going to use a emissive material. And all of a sudden, this sphere becomes our global illumination source emissive object. And as I mentioned, it works across the board from hybrid to smart to path tracer. but not in a standard renderer. There are ways to fake it, but basically this is one thing you cannot do without more complex computing that standard renderer does not offer. Right, so back to our scene. I will change the color of these bulbs. And I think I'm gonna apply a post effect there. So something like glow. Now, when I connect the glow to the root node, you will see that it affects the whole scene. However, I can choose to choose 3D geometry that would work hand in hand with glow and with nothing else. And I can do that by piping the 3D objects to the affected object input. So I'll grab all of those, connect it there. And now in the glow, I can say apply to opaque objects only. Now I can tweak this to my liking and this becomes a little bit glowy. Maybe red was not the best color. Something like this. Now obviously you can split up, you don't have to use same material for all of them. Let's say I'm gonna unhook it from those two, make a copy, and set this one to something like blue. As mentioned, this is a freeform workshop, so you do what you feel is right for your scene. One more practical tip before we finish this up. There might be instances where you're building your designs and you will want to use some intrusive post effects on top of it all. So let's grab something really aggressive. How about block glitch? So if I connect it to the root, and I'm trying now to work with the scene, you can see how very fast it becomes very hard to understand what's going on. You're not obliged to use post effects on the root or let's say nulls or loaders. You can actually apply it on the cameras too. If I now find the camera in the scene and connect that block glitch there, when I'm in an orb view, nothing is happening. But when I press 0, the active rendering camera, it's there glitching as it should for me. And that's just a better way to set up these crazy setups. When you're in an orb view, the working environment, it's not intrusive. And when you want to see the actual setup, actual design, you just click 0, go to the active rendering camera, and you will see that post effect applied there. So with that said, feel free to mess about with the scene as long as you like, get it to a state where you enjoy it, apply all of the techniques that we spoke of and learned. This is where I ended up with my scene when I was playing around with it a little bit earlier. And once you're done, let's see each other in the next chapter.